Welcome back to STEM for Others. Today we're going to be talking about machine learning. Okay, machine learning, what is it? Machine learning, or ML, focuses on enabling machines to imitate the way that humans learn, to perform tasks autonomously, and to improve their performance and accuracy through experience and exposure to more data without being explicitly programmed. So, if we think of the way that humans learn, it's often through experience, practice, and feedback. And this is exactly how machine learning works, through experience and feedback. There are some limitations to this, however, because of biases and influence that may sway how data is processed. And this is actually talked about a lot in ethics for AI, but that's not a big topic we're going to get into today, but it's something that is important to touch on. But the main takeaway is how machine learning can be similar to how humans learn and how more data and more experience will make the model perform better. Okay, why machine learning? So, machine learning is able to solve complex business problems. Traditional programming struggles with tasks like image recognition, natural language processing, and medical diagnosis. So if we have any sort of image classification, machine learning is good at picking out the different patterns or traits for a specific portion of the data that we're trying to classify something against something. It could be like images of dogs and cats. You're trying to classify an image of a dog versus an image of a cat. Machine learning is really good at picking up at specific traits of those animals. Some more examples are language translation and sentiment analysis. Handling large amounts of data. So machine learning, the data generated daily is immense. ML effectively processes and analyzes this data, extracting valuable insights and enabling real-time predictions. So while machine learning is really good at handling large amounts of data, there are many techniques placed to limit the amount of data that is processed to get a more accurate prediction or accurate insights on the model. So something that a lot of people use is data cleaning. This is just become more of like a fundamental step when you're creating a model, because a lot of the times the data pertaining to the model can have portions that aren't great and would cause inaccuracies and faults within the model. So a lot of times some data has to be taken out to get a more accurate model. And some examples of this are fraud detection and FYP recommender. Next is automated repetitive tasks. ML automates time-intensive and repetitive tasks with precision, reducing manual efforts and error-prone systems. So this really makes machine learning more effective and reliable because it is more accurate. And an example is email filtering. Okay, so the last thing we're going to be talking about is how does a machine learn? So this is just a really general outline. So with any algorithm, we have to input the data first. And once we input the data, say it's like a classification of images of dogs versus cats. So now we have to let the algorithm analyze these images. And once it analyzes the images, it's going to pick up on a pattern. This could just be like, again, the dogs, what are traits of the dogs that differ from cats. So that's kind of what we're looking for with the pattern. And by then, it's going to make a prediction about the problem that you input into the model. And then that's going to loop into the decision, which is usually a numerical value or anything that translates into a numerical value and will show your accuracy. Okay, here we have some visuals so we can really see how these machine learning models work. So for our first example, we have a classification of different fruits. Here we have apples, bananas, and mangoes. So this is our raw data, and then it's going to be put into the model. And once it's put into the model, it's going to go through training. And in training, it's going to be fed these, training images, and it's going to pick up on patterns and before it makes a final prediction about how well the model is at classifying these different fruits. And then after it's done with all of the prediction and the evaluation, the model is going to output 3 different fruits. So this is a successful version of what is going on. So it's separating the apple versus the banana versus the mango. So here the model was able to predict or pick out which fruits are which. And another example is with animals. So here we have some cats, frogs, and dogs. And then everything goes into the model training, where again the images are put in and the model makes predictions about or picks up on patterns about the certain images. And a lot of the times convolutional neural networks are used and different types of algorithms which are good at classification, and we'll get into those specifics later, but now it's just really understanding about the different steps that go into a machine learning model to classify 2 different things. So we have the training, which training images are put into the model, and then it makes a prediction about based on the patterns that it picks up on. And then this is from the testing data, and then it comes out with 2 separate classes for the dogs and the cats.